There are a few types of feedback loops that we need to go through for endocrine physiology. Let's talk through more of a standard negative feedback loop, and then we'll talk about how axes differ from these standard feedback loops. So oftentimes you have an endocrine gland that's going to secrete a hormone, and that hormone goes to a target organ, binds to a receptor, causes a physiological effect, and then you measure that physiological effect, and that is the negative feedback back to the gland. And you just go through this process. If that negative feedback isn't strong enough, you will continue to secrete the hormone. If negative feedback comes back and is high enough, you will stop hormonal secretion. So this is this general response. Axes are a little different. Let's go through how these work. In this case, you have the hypothalamus releases a releasing hormone, which then binds to the pituitary. The pituitary then releases a hormone, and then that hormone goes to the gland or the target gland, releases a second hormone, that goes to end organs, and then you have a physiological effect. It seems like a lot of steps, doesn't it? But why might this be important? Well, you are regulating here the hormone rather than the physiological effect. Let's go through the pituitary gland in a little bit more detail. The pituitary gland can be split into an anterior and a posterior pituitary. The anterior pituitary receives input from the hypothalamus. These particular neurons project down from the hypothalamus and go into the vasculature of the anterior pituitary. So there are direct signals that can be sent from the hypothalamus to the pituitary via this circulatory method. The posterior pituitary works in a little different format. Instead of using blood flow, it has direct neural projections from the hypothalamus to the posterior pituitary, and when it releases its substance, it goes directly into the circulation there. So again, anterior pituitary, hypothalamic nerve, releasing a trophic factor, which then bathes the anterior pituitary cells, versus the posterior pituitary, where you have the nerve going all the way to the spot at which it's going to release the hormone. Let's talk now through what are the cells that the anterior pituitary have, and what are those trophic hormones that are going to cause the anterior pituitary cells to release their substance. Those anterior pituitary targets for these trophic or releasing factors are either corticotropes, gonadotropes, lactotropes, somatotropes, or thyrotropes. The important thing to think about here is what are the cell type, what is it doing, and how is it distributed across all anterior pituitary cells. So somatotropes are going to be the most numerous. About half of the cells are somatotropes. Then we have both lactotropes and corticotropes, about 15 to 20%. Finally, gonadotropes and thyrotropes are the lowest ones with 10 and 5 respectively.